you. Good afternoon, everyone. Welcome to our session. And here we are going to talk about a topic that covers 2 Apache projects. My name is Xuefu, and here is my colleague, Bowen. We both worked from Alibaba. I just joined Alibaba last year from Uber. And prior to Uber, I worked at Cloudera for the Hadoop vendor. So over the years, like around 10 years, I have been working on the big data technologies, especially in the big data world, on many of those Apache projects. So that's why I'm able to cover something that's across, from a perspective, knowing the multiple projects. The 2 projects, Flink and Hive, has been looking at each other for quite a while, but now it's time to have a meaningful conversation, which is what we are here, why we are here today. A quick agenda for our conversation, for our talk, we have. I started to introduce the problems we're trying to solve with some context, what the problems in Flink and what's the urgency to solve them. Then that will give us a view of what the goals we want to achieve by solving these problems. Following that, I'm going to give you a brief overview of the technical aspects of our approaches, describing how we solving the problems. And then my colleague Bowen will take over and give you updates on our progress and our plan, and hopefully a live demo on the things that we have been developing. In the end, I will join Bowen for a Q&A session. So Flink, as we all experienced, Flink has been very successful in streaming processing, and its scalability and potential has been proven and pushed further by Flink, which now is part of Flink as well. So from at Alibaba, right? So we have shown that Flink is able to process extremely large amount of data at an unprecedented scale. So here is a slide that I borrowed from other presentations, showing that how Flink is used by many business units inside Alibaba and the data volumes. For example, at Alibaba, we have usage of Flink to process 1 trillion events per day, which end up around 1.7 billion events per second. So that's the scale that we are talking about. So while this is very exciting, right, we also observed that for a lot of streaming analytics, those can actually be expressed in SQL. So why do we want SQL? Because SQL, right, give you an alternative to write streaming applications without even writing any code. So you can write a SQL and deploy that SQL. To the user is a SQL to your cluster and run your streaming jobs. Of course, once we get into the business of SQL, we were talking about a lot of objects like tables, we have views and UDFs and things like that. So those things we also need to manage, right? And the first thing we need is a store. So how Flink is doing today? Flink currently store all the metadata in memory, and the organization is quite poor in terms of it's scattered around different components. There's not a streamlined organization of those metadata. So that give us a lot of things that we can improve upon, the usability, productivity, and interoperability, and manageability. So for example, right? So you for usability, every time you start your Flink session, right, you have to re-register all your tables, your functions, your views. So that's actually is counterproductive, and also is a very difficult to share between your teammates on those things. So this data introduced the first problem we are trying to solve is Flink lacks of a well-organized, persistent metadata storage. And from this morning's keynotes, we also know that Flink has started looking at the batch as well. That's so if we look at the streaming users, so many of them actually already have Hive installation in their data platform, and they have the needs for batch analytics as well. So another usage of batch processing is like ETL, right? So we have data lake, and the data lake where you want to process your data further for other applications. So you have ETL. Another driving factor we look at is the AI usage, where data scientists want to get the data, extract the data from the raw data in your data lake, and train and test their models, and then later on deploy their model in their possibly streaming applications. So all this actually also drive the usage of the batch processing. And SQL again is the main tool for processing data, like in terms of batch. But unfortunately, today Flink users, like for Flink users or in the Flink installation, you usually have to resort to other computing framework to do the batch processing. So we are hoping that the days for that will be over soon. And with our Flink's achievement in streaming processing, we are expecting that we were going to have a very promising batch processing capability as well. So here is an example, a slide that I borrowed from other presentations, and showing that Flink has greater advantages in streaming, in batch processing as well. And also this morning we saw that slides where it is actually show that when the data size get larger, the advantage of Flink actually is bigger compared to the computing solutions. And of course, once we move to the batch in the SQL, we actually have a stronger need for metadata management, and also we need some more SQL capabilities. Like we have different joins in batch processing, and now we are looking at the typical data platform. We can see that the Hive is still is a standard for a big data, for a data lake, and the center of the data lake or any data platform is I wouldn't say 100%, but the majority of them probably have a high metastore managing their metadata. But if we look at Flink today, right, Flink has no capability or access to the Hive data, and unless, of course, you can register some data which is in your Hive installation as tables in Flink, but that doesn't have to be so complicated. And of course, Slurry doesn't stop at just Hive, because Flink needs to actually access many different types of sources and things, like beyond the Hive, MySQL, like any key value stores, of course, like a Kafka stream. Those systems may usually have have different data catalogs. So the problem with today we have is that we don't want to have a customized solution for each of them. So rather we like to have a uniform access, uniform interface to interact with different data sources. And we also allow users to customize, provide their own implementation for the catalog APIs. So and also streaming is just if you look at the data processing or big data usage, streaming is just a small use case of the data applications. The bigger portion actually is taken still as the batch processing. And there are many users which are not streaming users, right? So we want to offer the same benefits that Flink can provide to those users. So that leads to a problem where we want to offer like a Hive user the same story, so that even they don't use streaming processing, they still can benefit from the potentials of Flink in terms of batch. So to summarize, so we have 4 problems. Here are the 4 goals we want to reach to solve those problems. For example, we want to define a uniform catalog API, allow user to access allow Flink to access different catalogs, or even user can implement their own. And in Flink itself, we want to offer a few commonly used catalog implementations. There are in-memory catalog to keep as a backward compatibility, and also a persistent catalog which is based on a Hive Metastore. And also we will implement a Hive Catalog, enable a deep integration for Flink with Hive. Then we also provide Hive as Flink as a Hive new execution engine. This is of course a long term. We'll get to that maybe one day. Yeah, I don't know when that will happen, but hopefully not that long. Maybe possibly this year. Here is I'd like to share some the overview on the technical side, describing how we are going to achieve those. We already have a proposal that's Flip 30, which has the details on the API that we defined. So if you are interested, feel free to look at that and provide us feedback. And also, as we said earlier, there would be 3 implementations in Flink, like generic in-memory catalog for backward compatibility. So we will, it's still in memory, but it's very well organized and has the same functionality as a traditional catalog. And also there would be a implementation that offers persistency for Flink metadata. Then we also have an implementation of a Hive Catalog, allowing Flink to access Hive metadata seamlessly. Beyond the metadata, we also have a Hive data connector that allows Flink to access read and write Hive data. And as I said, Hive on Flink is not yet planned, but hopefully it will happen soon. So brief architecture, this is the components stack, and we can see that the main thing here is we plug in the API in the table API in the SQL layer, and the rest of the thing actually stays the same, which is quite straightforward. And So if we expand that the catalog API in a bigger picture, like in the class hierarchy, we can see that the things are slightly complicated, but still manageable. So from a user point of view, right, user interact with the SQL client. SQL client sits on top of the table environment. Table environment has a reference to the catalog manager. So why we want to catalog manager? Because Flink allows you access simultaneously different catalogs. So those catalogs is described by the catalog API interface. And here are our implementations, the 3 implementations. This is the in-memory implementation. And we have this is a persistent catalog implementation for Flink metadata, and the Hive catalog implementation for Hive metadata. So the two, because we implement this based on Hive metastore, so we have a common parent that talks to a Hive metastore client. Inside the Hive metastore client, we also have a light shame layer allowing Flink to access different versions of Hive. And this is the data aspect of the integration. So we will have a Hive data connector. Flink actually define pretty well on the interfaces to access external data sources with the batch, with the table API and the source and the sync API and the input output from API. So on the read side, right? So Hive table factory create Hive table sources. And the Hive data sources provide access to Hive data through the Hive input format. So that is read side on the, in parallel with that, this is the right side. There's again the Hive table factory creates Hive table sync. Hive table sync can read or can write Hive data through the output format implementation called Hive table output formats. So, so that's just a very high-level technical. There are a lot of details on those. I mean, the API level is quite simple, but the implementation is quite complicated. So I'm going to skip that details and just give you an overview. If you guys are interested, we can share you with the detailed design, and also we can share how we implement those things. So having said that, so now it's time for my colleague, Bowen, who is going to give you an update on the current progress, like what's our future plan, and followed by a live demo. All right, thank you.
Yes, thank you. Hello? Yes, thank you, Xuefu. So hi, everyone. My name is Bowen Li, and today I will present you our latest progress, our development plan, as well as giving you a live demo at the end. So as you can tell from Xuefu's presentation that this is truly a major work. Thus, we decided to break it into several manageable parts. We first want to build a unified catalog APIs. Based on the API, we integrate Flink with Hive on both metadata and data layer. And finally, we want to support a complete set of SQL DDL and DML in Flink to give users a well-defined end-to-end SQL experience. So in the next few slides, I will compare like what Flink currently has and what our improvement looks like. So Flink currently barely has any catalog support. It also has separate catalogs for functions and tables, and the completely separate thing. So in our improvements, we introduced new catalog APIs and framework and connected them to CalSet for SQL Planner to use. Specifically, we developed a readable catalog and a readable writable catalog APIs, which can manage all those commonly used meta objects used in other database systems like database, table, view, partition, functions, stats, etc. And just to mention that we add true view support also in Flink right now, because Flink view right now is kind of like table, but we add true view support. It also supports a list of operations. For example, you can create something, drop something, alter something. And we also unified function catalogs with the new catalog APIs. So fundamentally, they become a single catalog under the hood. Flink right now doesn't have a well-structured hierarchy yet to manage all the metadata. To give you an example, Flink current catalog uses a cal set and allows endless nested subschemas in cal set. You can think of subschema as a database. What that means is you can have database under database under database, just goes on. It's not really intuitive. And the SQL experience needs to be much improved. So what we have done is we introduced a strict two-level management structure. Each object can be strictly identified via a catalog name, a database name, and the object's own name. We added a catalog manager to manage all the registered catalogs and help users to resolve object names. It has a concept of default catalog and a default database. So you can also change and set it all yourself. So when you're referencing an object under your default catalog and default database, a query like select star from this whole bunch of namespace can be simplified just as select star from my table. So that's a great improvement with regard to user experience. We also made Flink case insensitive to object names, which is similar to all the other popular data systems you use like Hive, MySQL, and Oracle, so you don't need to worry about any typo when using SQL. Flink right now doesn't have any production-ready catalogs, so we developed 3 of them. Generic in-memory catalog is for backward compatibility. Is a procession-based and non-persistent, so you lost everything when you restart. We also developed 2 persistent catalog, Hive Catalog and generic Hive Metastore catalog, which I will discuss just in a moment. So what does this unified catalogs API means to you? We have made catalogs to be pluggable, and we believe this opens a great opportunity for our developers and users to build catalogs for your favorite database or data management system. For example, your streams, message queues, your structured data and semi-structured data. We will probably implement some of the most demanded ones like Kafka in the future. And we welcome all the users contribute your implementations once we merge those API into the community version. So second, let's look at the Flink and Hive integration. And let's start with metadata layer. So we developed Hive Catalog, via which Flink can read and write Hive data. So for all of your existing Hive metadata in Hive Metastore, you can read it. You can read from Flink via Hive Catalog, and Flink can make use of all of them. Flink, you can also create some Hive meta objects and write it back to your Hive Metastore so that your Hive or Hive ecosystem tools can consume. We also developed the generic Hive Metastore catalog to solve the problem that right now your streaming and batch, not specific to Hive, your streaming and batch metadata is not persisted anywhere. So it also uses Hive Metastore as a storage. You might get a little bit confused, so let me walk you through the common part and difference. The common part they share is they are both backed by Hive Metastore as storage layer. But for Hive Catalog, it's specifically for Hive batch metadata. And both Hive and Flink can understand it. But for the generic catalog, it's persisting any streaming and batch metadata. And because of that, Hive may not be able to understand it. Let's look at the data integration. We developed the source and the sinks to read and write partition, non-partition tables and views. The source currently supports partition pruning, and we are planning to add more optimizations in the long run. With regard to data types, we currently already support all Hive simple and complex data types like array, map, and struct. We are working on supporting Hive user-defined functions. We already supported Hive's UDF, and the generic UDF, UDTF, UDF is on their way. We officially support Hive's 2.3.4 and 1.2.2 via streaming layer. And we rely on Hive's backward compatibility for all the other major versions in 2.x and 1.x, and we are also working, we want to support more of them directly. So with regard to timeline, our first targeted Flink release is 1.9, which will be around June this year. So it's about 2 or 3 months away, and we are working really, really hard to merge those features back into the community version so that you guys can enjoy a better Flink experience since June. So next, I will give you a live demo. I will demo 3 things with SQL, Flink SQL CLI. First is we can query Hive metadata in Flink. And then we will create a Hive source and sink with Hive Catalog, and then read and write data. And finally, we will create a CSV source and sink with generic catalog to read and write data. So first, let's look at here that I have a Flink local cluster and also HDFS and Yarn running. And first, let's look at the SQL client configuration file. So we defined a completely new set of configurations called catalogs. So you can define your catalogs here. So I have 2 catalogs, which is a Hive catalog and a generic catalog. And then we will run Hive CLI and Flink CLI side by side. This is a little bit like cut off. So we can do like show databases. And then we see the 2 catalogs I registered, which is generic and Hive also built-in in memory for backward compatibility. Then we do show databases. And we see show tables. Yeah. Oh, there's no table, okay. Okay, should I use we can switch your default catalog and database, like use. And then we can do show views. Show views. Then we can also look at their schema, like describe Hive table. This is a very simple table that I created for demo purpose. And then let's look at the second demo. Sorry. We can query the data here. Can query the table here. And we can also query views. This is just a simple view over the table. And then we can do, let's create a sink table. And then we can basically insert whatever in the Hive table into the sink table. And then we can query our new table here. So you see you got all the data. And we can even do a little bit more complicated one. Like this is a nonsense like join program that I just developed for demo purpose. What's going on? Never mind. Basically, once the data is in Flink, you can basically do all the windows joins and other things that Flink lets you do. So let's switch catalogs to to the generic catalog of Flink. I will delete this one. And we can create a source table and do select from my source. Then we create a sink table. So you can right now see it's persistent. It's persisted in the generic catalog. And we can query all of them. And the new file is created here. So that's my demo. And so as you can see, this is a major piece of work, and it cannot happen without help from other people. So we want to thank our teammates and also everyone in the community that offered help with regard to like designs, code, and feedbacks. So let me come to the conclusion of this presentation. Flink has been proven in stream processing, and it has great potential in batch processing. And that's why we developed this Flink and the Hive integration. And we believe it's going to benefit both communities. This has been a bigger effort, and it cannot happen without everyone's help. We are taking a phased approach, and all of your contribution is welcome. Last, I want to call for sponsors. We were going to host Flink Forward China in Beijing at December this year. All major Chinese companies going to be there. We are expecting the amount of attendees to be 3,000. It's 1,500, I think, last year. So if you are interested, please reach out to the email below. So thank you. That's our presentation.
Thanks a lot. Are there any questions?
So I saw, well, first, thanks a lot. That's great work. Yeah. So I have a question. So you actually right now have two places to define your catalog, right? One is I saw is from the SQL client YAML file. The other one is actually like you store that in the Hive meta store. Do I understand correctly?
How do you know? register a catalog right now, you can do two things. You can specify the catalogs in the YAML file as we showed earlier. The other way is you can use the table API to register catalog. So Hive Master doesn't store information about other catalogs.
I think.
Okay, so once the catalog is registered using the API, right, the DDL, where does it persist across section?
Not at the catalog level. So catalog you register, if you register through table API, that won't be persisted. The next time still you have to register catalog. So what we are talking about, the persistence is for things in a catalog, like tables, views, but databases, but not the catalog itself.
Okay. So right now the source of the choose, it's actually in the YAML file.
About catalogs.
I think you're it's a little bit confusing because right now you can also define tables, views, functions within the YAML file, right?
Mm-hmm.
The way it did that is because at that time it doesn't have a persistent catalog, right? So it's kind of using YAML file as a catalog. Mm-hmm. But in the long run, we want to move all those tables, functions defined in the YAML file to Hive Metastore and just use Metastore as a single source of truth for your metadata. And you register the catalog configuration in your YAML file.
Okay, great, thank you.
Yeah.
Any more questions?
Thank you. So I have a question with regard to unify the batch process and the streaming process. So for streaming process, we also like to define, the material, the view on top of the streaming process. So how this cover this part?
So not sure exactly. I understand your question well. So unified basically means in the same query you can access different data sources or things. So in your streaming application, you can join like a streaming source with like a batch source, like things data stored in MySQL or in Hive. So that's no difference between like the materialized view. So materialized view it seems like it's similar to a table, right? So it's just is backed by other table. So if you expand that view, there's no difference in terms of you concurrently access two different data sources, maybe managed by different catalogs.
So does that mean for the streaming job, we are also able to add that into the catalog?
Yes.
And also can join with join the batch system with the streaming system.
Right. So we haven't tested this, but we believe that should be feasible. So we haven't doing any testing yet, but at least that's our goal.
Cool. Thanks.
Sure.
Any more questions? Then thanks again.
All right. Thank you very much.
Enjoy lunch.